there be an advantage to, in the future, designing spacecraft that would have some spin or something to generate a slight gravity component that would mitigate some of the need for the hard exercise, for the concerns with bone loss and muscle loss? Just an open question, please.
You know, we've had some teams at NASA that have looked at that pretty intensively. Without getting really technical, the simple way that I can explain it is it's a lot easier looking in 2001: A Space Odyssey than it is when you actually get down to the engineering. So there are two challenges with it. One is when you're spinning a system, all your fluid physics changes again because you're basically operating a centrifuge. So your thermal loops, your pumps, all your liquids, you have to design completely differently than we do today for space or than we do on Earth. So there's a set of engineering challenges. There's also a set of human challenges because when you're spinning, you get a vector that goes just one direction. If you turn your head a little bit, it's like being on an amusement park ride. So it's not the panacea for the human response either. In fact, it could be worse than microgravity pretty significantly. So that's a short answer.
Marcia?
Associated Press, for the meals going up, are those all American-style meals, or are there other partners who are contributing Japanese food, European, Canadian?
I didn't hear the first word.
The food going up. Is that all U.S. supplied food?
Well, we do our food as USOS food for the U.S. operating segment, and then Russian food typically launches on the Progress. And that does always include a mix of things provided across the partnership. But I don't know the specifics of exactly what's in these food.
And for Dr. Smith, you're a nutritionist, correct? Out of, all the years that astronauts have been living on this space station full time, what have you learned about nutrition? Is there any particular diet that seems to be more conducive to a robust space life, coming back and all of that? I don't know whether you want to get any. I'd be just interested and curious to know what's working and what isn't working regarding food.
There's a lot of things we've learned. And, when I meet with the crews pre-flight, the first thing I tell them is, if I can only tell you one thing, it's that you need to eat. That getting enough calories, getting enough food, everything else will come along. All the vitamins and minerals come along with that. So that we're typically not cherry picking of, eat some more of this to get more vanadium. So energy consumption is the biggest thing, and that's, again, what we tend to drive home. And that is one of the things that was highlighted in the paper that just came out, that the crews that ate well and exercised hard, they maintained their body mass, meaning they didn't lose weight. They came back leaner. They came back with less fat, and came back again in pretty good shape. Beyond that, there's a number of things that we've learned either in a preliminary way or more defined way. From a bone perspective, a couple things come to mind. We published a paper a few years ago showing that the more fish you eat during spaceflight, the less bone you lose, and that likely ties back in with omega-3 fatty acids. We've got a study going on right now looking at the role of animal protein and potassium, which is the Pro-K experiment that I talked about, using the ratio of those two things in the diet to help mitigate bone loss. We're partnering with our European colleagues who have done experiments looking at lowering sodium intake as a way to mitigate, again, bone loss. So there's a number of things that I think we could optimize when it comes to trying to help bone the most. And then there's a number of other factors as well. Oxidative stress is still an issue that we need to look harder at. There's some potential nutrition components that we've identified that we're looking at further with relation to the vision issues during flight. So while we've learned a lot, we still have a long ways to go, but we're making progress.
James Dean, Florida Today. I think Ms. Robinson again. Are there, based on the way Dragon re-enters and splashes down compared to the shuttle's landing profile, are there any samples, any research that's considered too delicate that can't withstand return on Dragon, and so maybe you just wouldn't bother including them in down mass? And maybe Dr. Gateman, I wonder if that might be true for protein crystals.
It has been a concern in the past that the shear forces coming back down might just destroy the crystals, the fine crystals that are made. So one interest is to potentially image some of these crystals up in space before they come back down. So that's one thing we're looking into.
Yeah, so I mean, it isn't as smooth of a ride as landing on the shuttle was, but it is enveloped by the kinds of requirements that we get for launch as well. So we do worry about it for certain sensitive samples like some proteins, but you can also pack smart and pack things up, have things padded and so forth, and take care of at least that last, it's that landing part that's, plus the vibration and shaking. Those are the two kind of components that could damage things. So overall, things that can launch well can land well. It's just there are a few exceptions of things where you think about it.
Over here.
John Walkowitz from GOG News and Countdown Today. My question has to be about the bone loss and mass density. When you were talking about it doesn't have an effect when they return back to Earth, how long does it usually take a crew member or an astronaut to get that strength back or get that density back into the bones?
Well,
and that's for anybody.
Those are really two different questions, and it gets into some of the way we image bones. But what we showed in the paper last month, partnering with the Bone Lab and with the Exercise Lab, is that you can maintain bone mineral density. There is still a question of whether or not that bone is as strong as it was before flight, because there's some biochemical changes that we picked up in the blood and urine which suggest that it's not the same as as going back to having gravity. Okay, what we're doing is the exercise is increasing bone formation, which balances out the increase in bone breakdown, which is still happening. So we don't know enough about strength, and there's studies that are being implemented right now to look at bone strength to see if we're improving that. To go back to the other part of your question, it's been estimated it takes about 2 to 3 times the length of the mission to recover the bone. So from a 6-month flight, we're looking at 12 to 18 months to get back to full bone mineral density.
NASA and the Russian Space Agency collaborate and compare data from long-duration flights from their past programs to try to come to a result when it comes to bone mass and density?
We have a long history of collaborating with the Russians, going back into the 90s with the MIR programs, and especially on the medical side, there is a lot of discussion back and forth between the programs. With the research endeavors, at least our research tends to be focused on the USOS crews, who are the ones who participate in our experiments.
In the back.
Ronnie Williams, social media. Since we're on the subject of bone, you answered a couple of my questions. What's the percentage difference versus the early space program and now, since we've been examining this, that as far as bone loss, what's the percentage difference?
Okay. If I can have the last chart. This is actually an image from the paper that we published. It may take a minute. But what we did in that paper is we looked at normalized, if you will, bone mineral density loss per month, because that scales it out by the length of the mission. And what we have here is 4 bars. On the left is the MIR. The middle 2 bars are crew members exercising with the interim resistive exercise device, the IRED, as we called it. And the reason there were 2 splits there is because the IRED bar on the right, expeditions 14 through 18, are crew members that we collected blood and urine on during flight. So that's why we broke those out. And then you can see the advanced resistive exercise device on the right. So just looking at that, the average whole body bone mineral density loss was about 0.5% in those earlier programs, compared to essentially 0, if not a little bit positive, in crew members using the ARED. And we also looked at, again, in the publication, we looked at specific regions. We looked at spine, hip, you name it, and saw the same types of trends, but there's nothing more striking than that whole body picture. Thanks.
Okay.
I didn't plant that question.
All right, that's about all the time we have. Julie, would you like to make any closing comments?
Sure. So we brought to you today 4 different scientific perspectives of what's going on the space station. And just to kind of recap that, we talked about the diversity of disciplines. There's no other laboratory I know of with such international breadth and such breadth of disciplines that can do research that can't be done anywhere else. Then Dr. Yateman really talked about opportunity with cases growing offering new solicitations. There are opportunities far beyond what NASA's been able to offer in the past that are growing through cases management of the National Laboratory, and that's a really exciting development over the last year and continuing on. And then with Dr. Nielsen Price, you know, she's an example of new investigators who've never done work in space are getting access, finding opportunities to get the funding, and really ask basic questions, and that those experiments can happen pretty quickly. And then finally, what you saw with Dr. Smith was how our long-term investigators that get multiple flight opportunities over time can really start moving fields forward, make advances stepwise, and you really see that coming out in his work. So I hope that that gives you overall a sense of ISS as a dynamic and fully established laboratory. It's nothing like it was a year ago when people were mostly still talking about assembly. It's really full bore, full speed ahead with lots of opportunities. Thanks.
Thank you. And you can read a lot more about research aboard the International Space Station and the SpaceX CRS-1 mission that is launching to the space station by going to our website at www.nasa.gov/station. And our next televised event coming up here on NASA television is the SpaceX CRS-1 pre-launch news conference at 6 p.m. Eastern Time. And we'll see you then. Thank you very much for coming.